Hi everyone. In this video, I'll be discussing about the probable 10-mark question that might appear in the final exam of 2nd PU students 2022. This time there will be 3 questions instead of 2, out of which the students have to attempt any one question. The first question is going to be from linear programming and the second part of it is going to be in matrices. The 65th question also has 2 parts, that is the first one is from properties of definite integrals, the second one is from continuity, and the 66th question, the first part is from maxima and minima and the second part is from properties of determinants. We are not very sure whether they are going to keep the same combination, the first part and the second part, they might interchange also, but most probably they might keep the same thing also, because this I have done it according to the blueprint of the question paper. Let us now go through one by one these questions. The first one is the 64th question is from LPP. Here we'll have to maximize and sometimes it could be minimize objective function subject to the given constraints. So first thing is that we should have to write down the constraints. So let me answer the first question here. That is x plus 2y is less than or equal to 10, 3x plus y less than or equal to 15, x greater than or equal to 0, y greater than or equal to 0. Next, what we need to do is to write these given inequalities as the equations which actually represent straight lines. 3x plus y is equal to 15. Next, we need to draw the graph of these straight lines, for which we need to know at least 2 points. Therefore, I'm going to find out 2 points by drawing a table like this. So whenever x happens to be 0 in this particular equation, what will be y? Y will be equal to 5. And when y is equal to 0, x will be equal to 10. In the same way, let us find out 2 points in the other equation of straight line. When x equal to 0, y will be equal to 15. And when y is equal to 0, x will be equal to 5. Having found out 2 points from each of these lines, let us now try to draw the graph of it. So in the exam, you will have to do it on the graph sheet. So here, I'll do it without the graph sheet. So first thing is that let me try to draw the graph of the first equation, that is 0, 5 is on the y-axis, 1, 2, 3, 4, 5. And then the second point is 10, 0, that will be on the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Joining these 2 points, I get the graph of the first equation of straight line. Now, we need to decide which side is the solution region. Is it below the line or above the line? Usually, we take a point which clearly lies either below the line or above the line. The easy point we could take maybe 0, 0 itself and substitute in the given inequality. And if it satisfies, then every point which lies towards the point are actually solutions. If it doesn't satisfy, none of those points are solution, the opposite region must be the solution region. So the other way, what you could do is, whenever you have a less than or equal, and provided this is a positive number, you could simply say the solution region should be towards the origin. It is not below the line I'm saying it is towards the origin. That means this side. If it was greater than or equal, then it should have been away from the origin. Coming to the second one, we have the first point as 0, 15. So we already marked up to 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The other point is 5, 0, 1, 2, 3, 4, 5. It is here. Joining these 2 points now. Okay. Here also, since the inequality is less than or equal, the solution region must be towards the origin. And here there are 2 more inequalities. They are basically trying to say that both x as well as y must be greater than or equal to 0, and that happens only in the first quadrant, right? So we shall shade it this way. Yes. Now what is the common region here? The common region is this quadrilateral, and the corner points are 0, 0, 5, 0, 0, 5, and this one more point you have. If you had drawn it on the graph sheet, you would clearly know it, provided you have done it properly. Sometimes if you're not drawn the graph clearly, you might go wrong also. So I would always suggest that you solve these two equations of straight lines using elimination method or whichever that you find it easy, substitution or cross multiplication, and then get the point of intersection. And here in this case, it is, I think it is 4, 3. So having found out all the corner points, so let us draw a table here, having two columns. In the first column, we will list out all the corner points. In the second one, I'm going to write the objective function, that is z equal to 3x plus 2y. The first corner point is 0, 0. At 0, 0, the objective function z takes the value 0 itself. At 5, 0, z will be equal to 15. At 0, 5, z will be equal to 10. And at 4, 3, z will be equal to 12 plus 6, so that is equal to 18. Yes. So the maximum value objective function takes is 18 at the point of 4, 3. So the conclusion should be, therefore, the maximum value is 18 at 4, 3. This must be the conclusion. Sometimes what happens is you might get the maximum value at 2 points. In such cases, let us say you have got the maximum value at 0, 5 as well as 4, 3. So what must be the conclusion? Conclusion must be the maximum value is, let us say, 18 here, which occurs at 0, 5 and 4, 3, as well as at every point which lies on the line segment joining those 2 points. That is how must be the conclusion if the maximum value occurs at 2 points. But in this case, the maximum has occurred at only 1 point. So this must be the conclusion. Let's move on to the second part of the first question itself. So this is actually an easy question, therefore I don't want to solve it. A lot of students find it easy, and if it comes, I would always suggest you go for this question. So the first question here, the matrix A is given to us and a characteristic equation is given. So you could first verify whether it satisfies this characteristic equation, and then you will have to find out the inverse of the matrix, that is A inverse. So I'll just do half of it just to show you how it could be done. So first write down the given characteristic equation, then multiply throughout by A inverse. We'll do the left multiplication. When I say left multiplication, for every term you should multiply on the left hand side. So this becomes A minus 4 times A inverse into A becomes I, plus A inverse into I is A inverse itself, equal to 0. Now this implies A inverse is nothing but 4I minus A, and now you could substitute and then get the inverse of the matrix. Okay, yes. Let's move on to the 65th question. This question is going to be from the properties of definite integrals. There are actually 8 properties, out of which I feel these are the 4 most important. And if you study these 4, it would be more than enough, I feel. But here the problem is, along with the property, you will have a question too. This question may not be the same thing. It could change. So they could ask any question. So we'll have to be ready for the question also. So for the proof of it, I would suggest you to go through your notes or the textbook and learn these 4 proofs. Let's move on to the second part of the question. Here you will have to find out the value of k. Here there are 2 types of questions actually, though all of them are to find out the value of k. I'll tell you in what way they are of 2 different types. The first question you see, this is a given split function. It's split at 5, and on one side of 5 you have, that is for all x less than 5, you have it as kx plus 1. whereas on the other side, you have it as 3x minus 5. So on either sides of 5, the function has been defined in two different ways. But the second question you see, the function has been split at pi by 2. And at pi by 2, the function has been defined as 3. And on either sides, the function has been defined as k cos x divided by pi minus 2x. And on the other side also, the same thing, k cos x divided by pi minus 2x. So the function is same on either sides. So what must be the condition that we should use in the first case? Here the condition must be LHL must be equal to RHL. Find out the left hand limit and the right hand limit, equate them, simplify, you get the value of k. That's how you can find the value of k. But in the second one, what you should be doing is the limit of f of x as x is tending to pi by 2 should be equal to f of pi by 2. But what is f of pi by 2? It is nothing but 3, isn't it? That's what is given in the question. It is equal to 3. This is how you should write. Find out the limit of the function at pi by 2, equate it with 3, simplify, you get the answer. So let me just quickly try this question. It is a short question. The limit of f of x as x tending to pi by 2 could be written as limit of f of x. What is it? K cos x divided by pi minus 2x as x is tending to pi by 2 is equal to 3. This implies limit x tending to pi by 2. I'll make a little modification, that is cos x, I'll write it as sine of pi by 2 minus x whole divided by, taking out 2 common here, I get pi by 2 minus x, which is equal to 3. Let us now apply the limit. So here, this part, when you apply the limit, it becomes 1 using the formula sine theta by theta as theta tends to 0 is equal to 1. So we have, on applying the limit k divided by 2, which remain as it is, the next term becomes 1 is equal to 3. This implies k must be equal to 6. So this is how you could go about. In fact, the third and the fourth problems are of the first type itself. Let us move on to the 66th question, the last question. This time they are going to ask extra question. This will be from a Maxima and minima, and students might find it difficult, this question. And if you want to really go through it, please go through it, since we are not very sure of what could be the question they might ask, since they are asking for the first time. I would suggest you to go for the previous two questions, but if somebody is really interested, please practice this question and you could attempt this question. And the second part of it is from properties of determinants. Here also, there could be a lot of questions possible, but from the properties of determinant itself, a lot of students find it difficult. They get confused which operation to be used, and such a lot of confusion students have. But if somebody is really comfortable with this question, could attempt this question also. So let me try one question here, maybe the second question I want to try. So basically what I want to do here is to prove that the given determinant is equal to 5x plus 4 into 4 minus x whole square. So if I apply this operation, C1 is equal to C1 plus C2 plus C3, what do I get? I get the first column becomes 5x plus 4, 5x plus 4, 5x plus 4. The second column will remain as it is. Third column also remains as it is. Okay, now I'll take out the common factor. In the first column, we have 5x plus 4 is common. I'm taking it out. And what remains there? 1, 1, 1. 2x, x plus 4, 2x. 2x, 2x, x plus 4. Okay. Now, whenever you find 3 ones, what you should be doing is try to make any two of them 0. So let me make use of this operation. R2 is equal to R2 minus R1. and R3 is equal to R3 minus R1. So when I use this operation, what happens? You see, this is going to be 5x plus 4 will remain as it is. The first row is 1, 2x, 2x. Next row is going to be 0. This is going to be 4 minus x. This is going to be 0. Third row minus the first row again, 0, 0. And this is 4 minus x. Yes. The next step is 5x plus 4 into, look at this, students, this is actually the upper triangular, isn't it? So all these three are zeros here. See, these are all zeros here. Therefore, the determinant of an upper triangular matrix must always be the product of the diagonal elements. So the product of the diagonal elements is nothing but 4 minus x whole square. So this is the required answer. Yes, that's all for 10-mark questions, students. Wish you all the best. Do well in the final exam. Thank you.